Imagine waking up one morning to breaking news. A massive underwater volcano has erupted in the middle of the Pacific Ocean. But this isn't just any eruption. Over the course of weeks and months, something incredible happens. The volcano keeps growing, rising higher and higher above the waves until an entirely new landmass emerges from the depths. A brand new continent. Sound impossible? It's not. In fact, it's happened before, and it could happen again. Welcome to Imagine This, where we explore the extraordinary possibilities hidden within our world. Today, we're diving deep, literally, to answer the question, what if an underwater volcano created a new continent? What would that look like? How would it happen? And what would it mean for life on Earth? Let's find out. The hidden fire below. Beneath the ocean's surface lies one of Earth's most powerful and least understood forces, underwater volcanoes. Also called submarine volcanoes, these geological giants are far more common than most people realize. In fact, scientists estimate that about 75% of all volcanic activity on Earth happens underwater. These volcanoes form along mid-ocean ridges and subduction zones, places where tectonic plates meet, collide, or pull apart. When magma from deep within the Earth's mantle finds a weak point in the oceanic crust, it pushes upward. Most of the time, these eruptions go unnoticed by humans. The water pressure at great depths suppresses explosions, and the lava cools rapidly into pillow-shaped formations on the seafloor. But every so often, the eruption is powerful enough and persistent enough to build upward layer by layer until it breaks the ocean surface. Historical precedents. This isn't science fiction. It's happened multiple times in recorded history. In 1963, off the coast of Iceland, fishermen witnessed something astonishing. The sea began to boil and steam. Within days, a new island emerged from the waves. They named it Surtsey, after the Norse fire giant Surtur. Over the next 3.5 years, Surtsey grew to nearly 1 square mile in size. Today, it's a UNESCO World Heritage Site and a living laboratory for studying how life colonizes new land. More recently, in 2015, an underwater volcano near Tonga erupted and created a new island that merged with an existing one, expanding the landmass significantly. But here's the key question. What would it take for an underwater volcano not just to create a small island, but an entire continent, a landmass rivaling Australia, Antarctica, or even South America? To answer that, we need to understand what continents actually are. More than just size. When you think of a continent, you probably think of size. And yes, continents are large land masses, but geologically speaking, there's more to it than that. Continents are made primarily of continental crust, rock that's lighter and thicker than the oceanic crust that makes up the ocean floor. Continental crust is rich in minerals like granite and is less dense than the basaltic rock that forms oceanic crust. This difference in density is why continents float higher on the mantle than ocean floors do. Most volcanic islands are made of basalt, the same heavy dark rock that forms oceanic crust. This is why volcanic islands, even large ones like Iceland or Hawaii, aren't technically considered continents. They're built from ocean crust materials, not continental materials. The 7 continents, plus 1. Currently, Earth has 7 continents: Asia, Africa, North America, South America, Antarctica, Europe, and Australia. Though some geographers argue for 6, combining Europe and Asia into Eurasia. But there's an 8th continent hiding in plain sight, or rather hiding beneath the waves. Zealandia, a massive landmass about half the size of Australia, sits mostly submerged beneath the Pacific Ocean. Only its peaks, New Zealand and New Caledonia, rise above sea level. Zealandia has continental crust, making it a legitimate continent by geological standards, even though 94% of it is underwater. This brings us to an important realization. For an underwater volcano to create a true continent, it would need to do more than just pile up lava. It would need to fundamentally change the geological composition of the region. So how could that happen? The perfect storm of geology. Let's construct our scenario. For an underwater volcano to create a new continent, several extraordinary conditions would need to align. First, the volcano would need to sit atop a mantle plume, a column of extremely hot rock rising from deep within the Earth. Mantle plumes are responsible for some of Earth's most dramatic volcanic activity, including the Hawaiian Islands and Iceland. But our hypothetical plume would need to be massive and sustained for millions of years. Second, the volcanic activity would need to be incredibly prolific. We're not talking about a single eruption or even a cluster of eruptions. We're talking about continuous volcanic activity over hundreds of thousands to millions of years, building layer upon layer of new rock. Third, the region would need tectonic assistance. If the underwater volcano sits near a diverging plate boundary where two tectonic plates are pulling apart, new crust is constantly being created. This would accelerate the process of building a large landmass. The timeline. So let's say all these conditions exist. What happens next? Year 1 to 10. The volcanic eruption begins deep underwater, perhaps 3,000 or 4,000 meters below the surface. Initially, nothing is visible from above, but underwater monitoring systems detect intense seismic activity. The seafloor swells and cracks. Magma pours out in massive quantities. Year 10 to 100. The volcanic mountain grows rapidly. Within decades, it breaks the surface, creating a small island surrounded by steaming, turbulent waters. The island is barren, made entirely of fresh volcanic rock. Eruptions continue, sometimes explosively as lava meets seawater, other times more gently as lava flows expand the landmass. Year 100 to 1000. Multiple volcanic centers emerge across the region. What started as a single volcano has become a volcanic archipelago, a chain of islands like Hawaii or the Galapagos. The islands begin to merge as lava flows fill the gaps between them. The combined landmass now spans thousands of square kilometers. Year 1000 to 100,000. This is where things get interesting. The sustained volcanic activity doesn't just build upward, it begins to transform the crust itself. The immense heat and pressure cause partial melting of the surrounding oceanic crust. Lighter minerals separate out and rise, creating pockets of more continental-style rock. Meanwhile, sediments from erosion begin to accumulate, adding complexity to the geology. Year 100,000 to 1 million. Over hundreds of thousands of years, the new landmass stabilizes. Volcanic activity becomes less frequent, but continues to add to the landmass. Erosion carves valleys and mountains. Rivers form. The interior of the continent rises higher as the crust thickens and differentiates further. What started as a volcanic island chain has become a genuine continent with varied topography, different types of rock, and its own distinct geology. Size and scale. By this point, our new continent might be the size of Greenland or Madagascar, or possibly even larger, comparable to Australia. It would have coastal regions, interior plateaus, mountain ranges formed by volcanic peaks, and possibly even inland seas or large lakes in collapsed calderas. But what about life? Would anything be able to survive on this newborn continent? The first colonizers. Life doesn't wait for perfection. Even before our new continent fully forms, life begins to arrive. The first colonizers would be microorganisms, bacteria and archaea carried by ocean currents and winds. These hardy pioneers would establish themselves in cracks and crevices, beginning the slow process of breaking down rock into soil. Within years of the first land emerging above water, seeds and spores would arrive, carried by birds, winds, and ocean currents. Hardy plants like mosses, ferns, and grasses would take root in the volcanic soil, which, despite being barren, is often rich in minerals. Remember Surtsey, the volcanic island near Iceland? Scientists documented the colonization process in real time. Within 6 months, the first plant sprouted. Within a few years, birds began nesting there, bringing more seeds in their feathers and droppings. Within decades, a functioning ecosystem had established itself. The evolution of ecosystems. On our much larger new continent, this process would happen on a grand scale. Coastal areas would be colonized first, benefiting from ocean spray and milder temperatures. Seabirds would establish massive colonies, their droppings enriching the soil. Marine mammals might haul out on beaches to rest and breed. As plant life spreads inland, insects and other invertebrates would follow, carried by winds or hitching rides on birds. These smaller creatures would pollinate plants, break down organic matter, and serve as food for larger animals. Eventually, depending on the continent's location and proximity to other land masses, larger animals might arrive. Birds would be first, but mammals and reptiles could potentially reach the continent via floating vegetation rafts, chunks of land torn loose from other coasts during storms, complete with living passengers. This is how many remote islands gained their endemic species. A living laboratory. Over millions of years, the species that successfully colonized the new continent would evolve in isolation, adapting to the unique conditions. We'd see the emergence of endemic species found nowhere else on Earth, much like Australia's unique marsupials, or Madagascar's lemurs, or New Zealand's flightless birds. The new continent would become a living laboratory, showing us evolution in action, changing the map. The emergence of a new continent wouldn't just be a geological curiosity, it would have profound effects on the entire planet. Ocean currents. A new landmass would disrupt existing ocean currents, which regulate global climate. If the continent formed in a strategic location, it could redirect warm or cold water currents, potentially altering weather patterns across entire hemispheres. This could make some regions wetter or drier, warmer or colder. Sea levels. This might surprise you, but the formation of a new continent could actually lower global sea levels slightly. Why? Because the volcanic material that forms the continent comes from beneath the ocean floor. As this material rises and emerges as land, it displaces water. The effect would be small, perhaps a few centimeters to a meter, but noticeable over geological time. Climate impact. The volcanic activity itself would pump enormous quantities of gases into the atmosphere, including carbon dioxide and sulfur dioxide. In the short term, this could cause cooling due to aerosols blocking sunlight. In the long term, the CO2 could contribute to warming. The balance would depend on the scale and duration of the eruptions. Geopolitics. And here's where things get really interesting. Who would own this new continent? If it formed in international waters, there would be competing claims from nearby nations, possibly international disputes, and complex legal questions under maritime law. Would it become a new country, a nature preserve, a resource extraction zone, a new frontier? For humanity, a new continent would represent an unprecedented opportunity, a blank slate, unclaimed territory, a new frontier for exploration, science, and possibly settlement. It would be one of the most significant geographical events in human history. Back to reality. So, what if an underwater volcano created a new continent? As we've seen, it's not only possible, it's probable, given enough time. Earth's geological processes are constantly reshaping our planet. Continents drift, collide, and break apart. New land rises while old land sinks. The formation of a new continent would take hundreds of thousands to millions of years, far longer than human civilization has existed. But on Earth's timescale, that's just a blink of an eye. And who knows? Right now, beneath the Pacific or Atlantic Ocean, there might be a volcanic hotspot building toward the surface. In a few 100,000 years, our distant descendants might witness the birth of Earth's 8th continent, or 9th, if we're counting Zealandia. The bigger picture. This thought experiment reminds us of something important. Our planet is alive in its own way, constantly changing, never static. The Earth beneath our feet is not the same Earth our ancestors walked on, and it won't be the same Earth our descendants inherit. Geography isn't permanent, continents are temporary, and given enough time, even the most impossible seeming transformations become inevitable. Thank you for imagining this with us today. If you enjoyed this journey into geological possibility, consider subscribing to Imagine This for more explorations of the extraordinary hiding within the ordinary. Until next time, keep imagining.